Hello, and welcome to my presentation of tessellations all around us. Tessellations play a very important role in everyday life. You might not know it, but this branch of mathematics can be seen in numerous areas such as nature, art, construction, and many more. Let us take a deeper look in order to understand tessellations and in turn the world we live in today. First off, let's discuss what are tessellations. It is an overlay of individual tiles or shapes together with no gaps or overlaps. Another name for it is tiling. In every pattern a tessellation makes, one of the most important parts is the vertex, which is a corner or meeting point where the shapes meet. Another thing to note is that the interior angles at a vertex add to 360 degrees. In the succeeding slides, you will see how amazing these tessellations can be when you add different shapes and sizes together. Next, let's talk about the types of tessellations. One type is called a regular tessellation, which is a pattern made from a repeating regular polygon. Some examples are squares, triangles, and hexagons. A shape can only be a regular tessellation when the sum of interior angles must be a divisor of 360 degrees. So in the picture, you can see a square, triangle, and hexagon. Squares have an interior angle of 90 degrees, which is a divisor of 360. The same goes with the equilateral triangle, which has a 60-degree interior angle. Hexagons have an interior angle of 120 degrees, which also makes it a regular tessellation. Another type of tessellation is a semi-regular tessellation, and it is defined as a pattern made from at least two regular polygons. In this example, you can see that this type of pattern consists of two shapes, which are squares and triangles. Notice how there are no gaps or empty spaces in between the whole tiling. Other types of tessellations include 3D tessellations and non-periodic tessellations, which can be more complicated due to it being three-dimensional and non-repeating respectively. The example does a great job of using a cube to make a 3D tessellation. Now, let's talk more about tessellations. In the next few slides, we will talk about how the shapes in the tessellations repeat itself as well as its position through the whole pattern. One way a tessellation does this is through translation, where the shape repeats by moving or sliding. So in the photo, the triangle moves to the left by 5 units. One way we can express this is through an ordered pair denoted by xy, where xy is a point on the shape, and so it will be transformed to x minus 5y for every point in the shape. To illustrate this further, let's follow point B. From the coordinate 1, 3, it transformed to negative 4, 3 because it's, as stated before, the shape moves 5 units to the left. You can do the same with other points A and C as well. Another way a tessellation can move is through rotation, in which a shape repeats by rotating or turning. In this example, let's follow point N. Given the formula, we have to flip the x and y coordinates as well as making the y coordinate negative. Let us see how that affected the shape. Point N transformed to point N prime from negative 4, negative 2 to negative 2, 4, just like in the formula. If we do that for every point, we can see that the shape turned 90 degrees and the length of the sides flipped as well. One other way of transforming a shape in a tessellation is by reflection, which is the shape repeats by reflecting or flipping over a line. You can do this by negating either the x or y coordinate but not both. As you can see, point A transformed to point D, and the resulting shape is a mirror image of the original shape. The last transformation I will explain is dilation, and this is where the shape is enlarged or reduced. This is done by multiplying the same number to the x and y coordinate. Looking at the example, since point A to point A prime transformed from 2, 2 to 6, 6, we can say that the new square is 3 times larger than the original square, given that 6 is 3 times larger than 2. Now that we understand how tessellations work, let us look at some examples in everyday life. Art is one of the most common places you can find tessellations. because there's a high demand for artworks that incorporate tessellations. One example is MC Escher, who is a world famous graphic artist and known for his artworks on tessellations. One of his artworks sold for about $120,000. Another example is from architecture. The Moors were fond of using Islamic architecture when they ruled Spain for a short time, and in that time they constructed their palaces and fortresses using tessellations just like in the picture. This is a wall in the palace found in Granada, Spain. Now, let us see the application of tessellations in other disciplines. The first disciplinal perspective is through nature or science, and the bee honeycomb is a great example of tessellations in nature. The hexagon shape allows the honeycomb to be more compact and therefore more efficient in storing honey. In this example, I will explain why the bees chose a hexagon to store their honey and not other shapes like a circle. In this picture, it is very obvious that there are no gaps whatsoever in between the hexagons, making it an efficient use of space, as well as the compactness prevents any honey from spilling through the cracks of the honeycomb. If they use circles, on the other hand, there are very big gaps in between the shapes, causing the honey to spill, and their hard work was for nothing. Great job from the bees that they were able to figure this out. And finally, the second disciplinary perspective is an application in manufacturing. Using tessellations can help with cost cutting through efficient use of space or material, especially in manufacturing a product. In this example, I will explain how tessellations are effective in manufacturing t-shirts. Here we are given a piece of textile or cloth, which is the material used to make the t-shirts hypothetically given by the box. If we do not use our knowledge on tessellations, we will lay out our shirts somewhat like this. From the perspective of an ordinary person, this looks like an acceptable way to lay out the shirts given the constraints of the box. But to someone who has knowledge on tessellations would notice the spaces in between the shirts and he would rearrange it like this. By simply using what we learned a while ago on reflection, we are able to fit 5 shirts per row now, which allows us to make 3 more extra shirts than the other one. Look at the red circle in each box. By utilizing this space, we are more efficient in using our limited material. Now you may ask, it's only 3 shirts. What is the difference? Well, if you are printing thousands of shirts, it makes all the difference because for the same amount of material, you can manufacture more shirts. It is also important to note that I just applied one way of transforming tessellations. If more transformations were applied here, then it is highly possible that more shirts can be printed within that same length of material. Such is the beauty of tessellations. Thank you for listening. I hope my presentation on tessellations all around us helped you to appreciate more the patterns and shapes all around us.